Number one, the kappa opioid, down at the bottom. You guys are familiar with salvia divinorum? Anybody here ever do salvia? It's a kind of a weird trip. Well, it actually works at this kappa opiate receptor, which, contrary to the way it sounds, is dysphoric, a stimulant, and it makes you nervous, really. It's the opposite of heroin. What it does is it makes it so that you don't overdose, right? Because, you know, say you get in an automobile accident, you lose your arm, you go into shock, you don't feel it, right? But you don't want to have respiratory collapse from the big moo effect of the endorphins. So you start producing this other thing to counterbalance it. The interesting thing is that the kappa effect, over time, turns around and makes the moo work better. So it's, you know, the body is a wonderful thing. Second effect from the bottom is this same effect as Wellbutrin. Wellbutrin is a cigarette, you know, is given for cigarette addiction. And this is the one effect, this and the kappa are the only two effects that 18-MC and ibogaine have in common. So there's one group of people who believe that these two effects must be the therapeutic effect, since that's the only thing in common. You kind of like, you know, Venn diagram. But the one on top is the thing that is serotonin, and they were trying to eliminate this with 18-MC because LSD does this, right? And they didn't want to be like LSD. And it turns out that there is no long-acting metabolite that mimics Prozac, right, really, from 18-MC. But it is very important with ibogaine, and it gives people this glow. It gives them this, you know, this great feeling for about 6 weeks, which, you know, when you've given up your drugs is a good thing. Now, this is something that they got rid of. This is the one that makes you vomit and gives you car sickness when you do ibogaine. And I don't want people to get sick, right? But, you know, as I'll show you in a minute, there's something else ibogaine does that 18-MC doesn't do. Now, this is a little bit, this really is worth about 3 minutes of your time, because this is where marijuana and ibogaine intersect. There's this thing called glutamate. You've all heard of monosodium glutamate? The MSG, they put it in Chinese food to make it taste good when it really doesn't, right? Well, glutamate heats things up, right? It's an inflammatory. And marijuana is an anti-inflammatory, and basically back signals to the glutamate firing cell saying, hey, you're heating up the room, turn the thermostat down, right? It also is in this particular thing, it's implicated in a stroke. And, you know, marijuana is a tonic treatment for stroke. If you've had a stroke, it's a good idea to smoke a little bit of pot every day, because it'll keep your glutamate in check. And when you, basically, when you have a stroke, you have like a little blood clot that forms that keeps some of your cells in your brain from getting food and oxygen. And they start dying, and they freak out, and they send out glutamates to the next cell. And then it, you know, comes into the next cell. See where there's a key in the next cell? Right up the top. NMDA glutamate is like a key, a lock, right? It turns the lock. And what it does is it opens this channel, and calcium gets into the cell and kills it. So you had started out with one little tiny blood clot, and pretty soon you lost half your brain. Well, they had a drug called Merck drug 801 that stopped stroke, and they discovered that ibogaine had this effect too. So they went back and looked at Merck drug 801, or disosulpine, and they found out, lo and behold, it has anti-addictive effects just like ibogaine. So this is another group of people. There's a group of people who study ketamine a lot, and they want to use ketamine to treat drug addiction, and ketamine works at the NMDA receptor. And they said, well, we don't really need to study ibogaine, we can study ketamine, which is what we wanted to study to begin with. So you see all these people have a drug, like the one group of people has 18-MC, these people have ketamine. They don't really want to study ibogaine, they want to study the drug they already want to study. But there's a really interesting thing about this, and that is that they got rid of the metatropic 5 pathway, glutamate pathway, in mice. And the little mice could not be trained to inject coke. All the wild mice inject coke until they die. They don't drink, they don't eat, they don't fuck, they just inject coke until they die, right? But these ones, where they knocked out this glutamate pathway, they couldn't train them to pay attention to the coke. They drifted back to ordinary mouse life. So, you know, what they discovered was that glutamate is vital for long-term memory. It turns short-term memory into long-term memory, kind of like burning a disc, right? Because it's an inflammatory, it heats things up a little bit, it makes a long-term memory. And without that effect, no addiction. So, you know, that NMDA receptor effect may turn out to be important. But I'm going to go to the next thing because I'm in a real hurry here. And this is the real deal. This is, you know, we didn't even know about this when I started. Remember, I started in 1980. We really got going about 1990, the beginning of the medical marijuana thing. They found out in around 2005 that ibogaine expresses a growth factor called GDNF. And GDNF regenerates dopamine neurons, so you don't need artificially high levels of drugs all the time to feel normal. So not only does it do that, it back signals to the cell saying, keep making the GDNF. So you can take the ibogaine away because you have this loop where you're causing the cells to grow and you're making more growth factor so that you don't need more ibogaine. Now this just shows the effect of methamphetamine. You notice in the lower panel there's less of those dendrites, there's the tracery things, there's like little ropes, and there's less cell bodies. And that's really what happens when you do crystal meth. You decrease your ability to feel your own dopamine. After that, you need crystal meth all the time just to feel normal. Now here is what happens when you express the GDNF. You look on the right side, within 48 hours the cells have extruded dendrites and they're basically in communication with each other. So this doesn't take very long, and actually it doesn't take very much ibogaine. But I think the important point was that 18-MC does not have this effect. So the synthetic that they came up with may never work as good as a natural plant product. Sorry, Charlie. This shows how much it increases in 6 hours. It's a 12-fold increase from a low point up to a high point. That's a really big increase in GDNF. So this is how it works. Basically, the GDNF comes in, it goes into the cell, does this whole chain of phosphorylations, goes down to the bottom of the cell with the Krebs, which is a binding protein, and it actually hooks into the DNA and it makes messenger RNA.